Hello everyone, my name is Vanarahul. I am pursuing Electronics and Communication Engineering in the Oxford College of Engineering. First, I need to thank emertxe team for giving this great opportunity to learn embedded system. And based on the learning, we have worked on a project that is microwave oven. This project is built in a group of three. Once again, my name is Vanarahul and my teammates are T. Abhilash and Sri Ganesh Bobu. During the internship, they have covered these many topics. First, they have started with the introduction to C, data types, modifiers and qualifiers, and conditional statements like if statements, while statements, and switch statements. And third, operators and arrays and pointers and functions, variables and storage class keywords. Tools installation. In that MPLAB XID is used to write the code, and we use XE8 compiler for the code, and Pixie Blab for hardware integrating, and then introduction to embedded systems and microcontroller, and GPS VSES, introduction to various peripherals of 16F877A microcontroller, which we will use for our project, and project requirement and design, embedded C programs for interfacing LEDs, matrix keyboard, and 60x4 LCD, and buzzers, ISR, and cooler. All these codes we will use in our main program. And in this workshop, they taught us about career building and resume preparation. Coming to introduction to embedded system, as the name specified, embedded, it is embedded with hardware and software, which is intended to do a specific task. Like example, microwave oven, rover, washing machine, CCTV camera. First, microwave oven. It is intended to perform a specific task like cooking. And a rover, it will take a sample from a space and it moon or in somewhere. It will send the information to Earth. And in rover, there are so much of embedded system is integrated. And washing machine it is used to perform only washing. And CCTV camera it is used to only for monitoring. Coming to microcontroller. In simple words, we can say that a microcontroller is a small computer on a chip. As shown in the block diagram, it consists of a CPU, RAM, input, output, and ROM, timer, serial port. So we will say that it is a small computer on a chip. Coming to GPS vs ES, GPS stands for General Purpose System and ES stands for Embedded System. A general purpose system is designed to perform a wide range of tasks and applications. An embedded system is specialized computer system designed to perform specific task or function within a larger system. It will do a intended task only, but it is used for a wide range of tasks in the general purpose system. Now, general purpose system can be used for a wide variety of tasks from word processing, web browsing to gaming, content creation. It all contains an operating system. And embedded system typically used in a specific application such as automotive control system, medical devices, industrial automation, consumer electronics. It will do a specific task only, not more than that. Usually consists of a standard set of hardware components like CPU, RAM, storage devices, and peripherals. In case of an embedded system, hardware is tailored to a specific requirement of the embedded application. Based on our application, we can design its hardware components. And example for GPS is desktops, notebooks, smartphones, and tablets. All this contains a operating system. But in case of embedded system, microwave oven, ATM, traffic light, automatic gates, it will not contain an operating system. Microwave oven is used to perform a only for cooking only. ATM is for money vending only. Traffic light is used to lights. Okay. Now coming to PiximLab peripherals and hardware. It consists of a microcontroller. We will use 16F877A microcontroller. It is a 40-pin IC and it consists of a LCD display. We will use a 16x4 LCD display and keys, buzzer, fan, timer. And this is the Big Sim Lab architecture which consists of a RS-232 cable and LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, 8 analog to digital converter, LM35 temperature sensor, I2C, RTC for EEPROM, GP, general purpose input output. Okay, next coming to PIC 16 of 8 sensor on a micro pin diagram. As I said, it is a 40 pin IC. Every pin is configured for a specific function. Let us go through that. Okay, these are the pins functions here. Like okay, coming to our project microwave oven. A microwave oven is a relatively small box-like oven that raises the temperature of food by subjecting it to a high-frequency electromagnetic field. We all know that it heats our food by electromagnetic radiation. Uh, we know that what a microwave oven consists of. It consists of a timer and alarm. After a time, we will be in a far distance, so it consists of a buzzer. Okay, coming to features. It consists of a micro mode, grill mode, convection mode, and a start. In micro mode, we can adjust the cooking time and power level if needed. In our project, the maximum power specified is 900 watt. And in grill mode, this is useful for making dishes like grilled cheese sandwiches or eating frozen items. User can set time accordingly. Coming to convection mode, some microwave oven come with convection cooking capability because we can preheat the micro oven before we start cooking. In our program, we have set maximum temperature is 180 degree and it takes up to 180 seconds to preheat the oven. And the user can set time based on its need. Let us come to start mode. It consists of a resume. If we press again start mode while timer is running, it will increment by 30 seconds. And the requirements for doing this project is we should know about the pin configuration and then basic embedded C program. And we should have installed MPLab XIDE and we should have XE8 compiler for compilation and Pixim Lab with PIC16F8778 microcontroller and 16 cross 4 display, LCD display, and a matrix keeper, cooler, buzzer. Let us go to our project program. Okay, this is our program in which we are including our main header file main h, which consists of all. Wait a minute. Okay, it consists of in which we have defined everything: power on screen, menu display, micro mode, grill mode, and included 16 cross 4 LCD display and matrix keeper and timers. Now coming to main program. First, we are offing the watchdog timer. Watching timer is disabled first. First, we are initializing our LCD and matrix keyboard. Okay. If key 1 is pressed, operation flag will be go to micro mode. It will come to a switch statement. We have used a switch statement. Here micro mode. In micro mode, it will set time key comma reset flag. It will go to this location. Okay. Here it is. It will come here. In this, it will set seconds and minutes. And we are using blink for blinking the time. Then if we press key is equal to 2, it will go to grill mode. And if we press key 3, it will go to convection mode. And reset flag will reset flag will be equal to mode reset. And if we press key is equal to 4, it will go to start mode. Okay. Okay, coming to Pixim Lab. Okay, I will reset it. First, it will display powering on screen. Okay. First, we will check micro mode. I will press key 1. It will display power is equal to 900 volt. Now it is blinking. Now I will enter. First, I will enter 1, 0, 0, 1. It enter 1 minute 10 seconds. And if I press star, it will clear everything. And if I press hash, it will enter. It will start. If I press 4, it will increment by 30 seconds. Look, it is went 36. If I press 5, it will pass the everything. The fan will be off, everything will be turned off. Timer also paused. If I press 4, it will again resume. If I press 5, it will pause. If I press 6, it will come out of it and it will show the menu. Okay, wait a minute. It came to menu. If I press again, I will press micro mode. Power is 900 watt and I will give it 10 seconds and I am entering it. After the time is become 0, the buzzer will on and it display timer. Now it will again come to display screen. Now if I press 2, it will go to same as it is. It will set time directly. We can set the time accordingly. Same. Okay, I will press 10 and enter. Okay, I will stop it. 6. Okay, it stopped. Now for preheating purpose, I will use convection mode 3. Okay, if I enter a value greater than 180-degree, it will show enter a value less than 180. Look, I will enter value as 2, 5, 0. Look, enter temp less than or equal to 180. Till again it will come to same. Now I will enter 140. Enter. Now it will 180. I have for showing I have kept for 18 seconds. After 18 seconds, but in program I have kept for 180 seconds only. Now it come for a time display only. Okay, let me keep a timer for 10 seconds. Now the microphone is preheated. Enter. Now after time becomes 0, it will on the buzzer and it show timer. And again it will be even to okay. Then if I press 4, it will start with the 30 seconds. And if I press again 4, it will increment by 30, like 55, and same as it is. If I press 6, it will come out. See, that's all. The fan will also off. Okay, thank you.